my friend Callie, and today we're going to learn about the Lyon Hypothesis and figure out why she's colored the way she is. We must first understand the Lyon Hypothesis to understand why Callie is colored in the pattern she is. So the Lyon Hypothesis is the random inactivation of an X chromosome. The inactivated X is called a Barr body. I have two examples to share of how Barr bodies and the Lyon Hypothesis work. The typical female has two X's, so they would have one Barr body. One X would be activated and one X would be inactivated. But a typical male has an X and a Y. Since they only have one X, they would have 0 Barr bodies. Now that we know a little bit about the Lyon Hypothesis and how Barr bodies work, we can get into how my friend here, Callie, is colored. Since Callie is a female, she has two X's, meaning at any given point she has one inactivated X Barr body. Callie's genotype is X big B, X little b. The big B gives off a black pigment, the little b gives off an orange pigment. So as we can see here in the orange pigmented part of Callie's tail, she would have a big B Barr body, and the activated gene would be the X little b. But as you can see in the black part of Callie's tail, the little b with the orange pigment would be inactivated, and the big B with the black pigment would be activated. And this would be like this everywhere that she is colored over her body. Callie's color pattern is referred to as tortoise shell. You might have been wondering why I've only been referring to Callie as a girl and why her example was a female. And that is because typically males do not have an inactivated Barr body to give up. They're typically XY, meaning that if they have X big B, they would be a black cat. If they were X little b, they would be an orange cat. There is one case where a male cat could have this tortoiseshell coloring, and that is if they had Klinefelter syndrome, where they have two X's and a Y, meaning one X could have a big B, one X could have a little b, and they could have this tortoiseshell coloring. I'm going to now demonstrate an example where we mix sex-linked traits with autosomal traits. We're going to mix an orange short-haired female with a black male that's heterozygous for long hair. Please note in this case that long hair has the dominant gene and short hair has the recessive gene. So when we do this combination in a Punnett square, we get a 1-to-1 ratio of one long hair to one short hair. Now when discussing the sex-linked colors, when we mix the black male with the orange female, we're going to get a 1-to-1 ratio of one tortoiseshell females, as you can see here, and one orange male, as you can see here. Here's what my previous example would look like as a branch diagram. To close this off, I have a little fun fact to share about tortoiseshell cats. Did you know that a clone tortoiseshell cat would not look the exact same as their mother? Why, might you ask? Because they both have the same genotype. The answer all relates back to the Lyon Hypothesis and how X chromosomes are randomly inactivated. So as you can see in this mother cat, the big B black pigment was inactivated on its face right here. But in its cloned version, the little b for the orange was inactivated on its face. It all goes back to the randomness of the deactivation. I hope that everyone enjoyed my video.